talk about wave equations. So in boundary value problems, there are various types of partial differential equations. According to the scenario, we can apply a particular equation. Maybe we have heat equations. When we are going to the previous discussion, we are talking about heat transfer. There we can apply heat equation. Here, if you are in this problem, in this concept, I am going to talk about wave equations. So that I am going to connect wave equation of the given problem with the real time scenario. For example, let us assume there is a spring, or there is a band or kind of an elastic material. Let us assume. See, so here there is a point and here there is another point. So in between this, there is a band tied on both sides, maybe A and B. Let us assume. So what I am doing is, maybe let us assume this is the center point. This is the center point. I am holding this and I am pulling up and I am leaving it. What will happen? You will have some vibrations. You have some vibrations. Am I right? You have vibrations, is it? So when you pull a rubber band like this, whatever, then if you leave, there will be some vibrations. Am I right? There will be some vibrations. So the vibrations are the kind of wave motion. Am I right? The vibrations are the kind of wave motion. So if there is a scenario, suppose this particular guy wants to know what is that, sir? How do I measure that displacement? Suppose if I say that the wave motion is like this. The wave motion is like this from A to B. The wave motion is like this. If suddenly he wants to know, so the displacement or the wave motion, maybe from here to here, here to here, he wants to understand the displacement with respect to the distance and time. I am telling you two parameters here. He wants to know, so I am talking about two dimensions. That is, I am talking about distance and time. If he wants to know the displacement of this wave motion with respect to distance and time, maybe the next 5 minutes, next 10 minutes, what is the displacement? If he wants to know, he can calculate this using boundary value problems. We can calculate this using boundary value problems. So we can work with one dimensional and also we can work with two dimensional. We can go on like this. Okay? We can go on with this. We can, so according to the real time situation, we can work on. So here I am talking about, listen, here I am talking about only x-axis. Okay? Here I am talking about only x-axis because the wave motion is along x-axis. The wave motion is along x-axis. So how many dimensions I am using here? One dimension. How many dimensions I am using here? One dimension. Even you can work for 2 dimensions, 3 dimensions. You can go for n dimension depending on the scenario. Okay. So now, so in this concept you will see, as I told you in boundary value problems, we have some boundary conditions. You can go on solving them. So we have certain boundary conditions and some initial conditions to be understood. Okay. So before starting the experiment, what is the displacement at the endpoints? What is the displacement at the endpoints? Suppose if we are going to start the experiment, at the present starting experiment, then do we have any displacement at the endpoints? You will not have any displacement at the endpoint. Am I right? So suppose if I say this is x equal to 0, maybe this is 5 centimeter long. So I will say, maybe if I say y is the displacement, so y is the displacement of this, maybe if I say y is a displacement with respect to distance and time for this particular value a, I can say y of 0 comma t is equal to 0. Do you agree this? So what I am telling here, the displacement at the point x equal to 0, the end point, x equal to 0, the displacement will be 0. There is no motion at the end point. Similarly, you take this point, 5. So it's the same scenario. I can move on maybe this end point to that end point. In the initial stage, there is no displacement here at the end point. So y of 5 comma t is also 0. Am I? This is one simple example, but you can go on extending this. So if I write in general, x equal to L, the length can be anything. But in the end points, I say there is no displacement. So I can say y of L comma 0, y of L comma t is equal to 0 because no displacement in the end points. But he wants to know, so what is the displacement maybe at this particular point at a time t equal to 5. If he wants to know, so what is the displacement at this point when t equal to 10 minutes or 20 minutes. So as an engineer, you should be able to see what is the displacement taken and happened there. Okay. So in that scenario, we can use the wave equation model and we can work out the scenario. Okay. Then we can derive the solution. Okay. Thank you.